How many people here are super excited about the fact that we get a new building code that comes into effect on December 10th? Everybody sharing on that? How many people have rolled up their shirt sleeves on that yet? But today what I want to talk about is the energy step code, because this is the one that makes things real for us. And I want to just stand back and take a real high level look at what's going on with the step code. The National Building Code for Canada is a model code that is available to all of the jurisdictions across Canada, typically provincial or territorial, but it's available to any authority having jurisdiction that wants to write their own code that participates in the national program. So City of Vancouver, by example, don't subscribe to the BC Building Code, but they do subscribe to the National Building Code process so that they can use it as a model when producing the Vancouver Building Bylaw. In there is typically where the motherhood changes happen, and then provincially and regionally, these changes in building code are either adopted verbatim by the different regions, the provinces, or the City of Vancouver, or independent authorities. And but they have the privilege of tweaking it out slightly to make it more BC-centric or Vancouver-centric, obviously. And what we're seeing in the code changes is the actual law of the land for everywhere except the City of Vancouver in British Columbia is the BC Building Code. And it is now the BC Building Act, which makes it physically law, which means you're breaking the law if you don't attend to the building code. It's kind of interesting that the authority of the building code is gaining a fair amount of teeth, so that under regulatory reform, there's a clear distinction between what the municipalities and your building officials have purvey over versus what the province has legal purvey over. So in a nutshell, the last building code, they sort of brought in this thing called regulatory reform. Most people didn't really understand what it meant. Basically what it means is if it's in the BC Building Code and you're in BC outside of the City of Vancouver, the BC Building Code is the final word. So if you've got a building official out there who says, oh yeah, I don't care what the code says, I want this, or if you're in a municipality that's written a bylaw that supersedes, amends, or changes the building code in any way, it's actually illegal. It's not something that they have privilege on. But there are many things that the authorities have in jurisdiction do have authority on because they're not in the building code. That's what the step code is. The step code is intended to take, for small structures, Part 9, and in specific terms for energy, 9.36, where we got that 100 some odd new pages of building code for small structures on how it is we're supposed to deliver on energy performance. Air tightness, vapor diffusion control, hydrothermal performance and impacts as we increase insulation, all that crazy information that we got in 936 is really the rules of engagement. But in 936, if you build to a minimum standard, it turns out houses haven't been that much more energy efficient than they were prior to 2014 when that all came into effect. So it's the rules of how you build high energy, and there's no real limits on how far you can go in there. And the minimum achievement under 936 in the Energy Code in British Columbia, which is a fairly close model of the national model for that, if you achieve that, you're really not gaining huge levels of energy performance. So really what British Columbia was wrestling with for a period of time was, do we just keep knocking up 936 minimum performance and make it the law of the land, and then everybody's just going to see a level escalation in energy performance on new homes built from code to code to code? And they took a look at that, and they looked at what their political commitment was, and the political commitment nationally and provincially, nationally, is that all new homes built by 2030 will be net zero or net zero ready for energy. In layman's terms, plus or minus twice as energy efficient as you build right now. That's a big jump. The provincial goal, softly spoken, is by 2032, because we chase the national code process, which happens on the 5s and 0 years. We're usually a couple years behind. This time we're actually 3 years behind. We've got an 18 based on the 2015 national code. So to keep it simple and keep it high level, 936 is the rules of engagement. The declared targets that we're going to are almost twice as much energy efficiency. the recognition is we're not just going to make a quantum leap and go from where we are now to there. And so it was decided we needed to have a level-stepped approach, but it was also recognized we're basically about 10 years out, which would mean arguably we'd only have 2 code cycles, so what are we going to do, go halfway there and then all the way there? That didn't seem to make sense either. And then when they spoke with the authorities having jurisdiction, they said, you know what, energy, although how you achieve energy efficiency is part of the BC Building Act, how far we want to push that, we believe, is a regional concern. And the provincial government agreed with that. And so this is the result of sort of all of those levels of recognition on the fact that we need to have a logical approach where we can get incrementally better and learn how to build in reasonable bite-sized chunks as we head to this great target. And that the local authority having jurisdiction should really be the thing that governs what happens specifically in that location. So the step code decided we're going to divide things into 5 logical steps. Basically, step 1 is doing what you currently can do under 936 energy. And for those who are building currently, you know in 936 energy provisions you have 3 methods that you can conform. You can just follow prescriptively through the 80 to 100 pages in there, or you can generally follow that but exercise your privileges for a couple of trade-offs that they had. If you do this better, you can do this a little worse. Turns out in BC the trade-offs are really limited because we also have an Energy Act in British Columbia. So you have to make code and you have to meet the Energy Act. And some of the things you're allowed to mess around with under the building code in order to trade off one for another, you're not allowed to go below those thresholds and trade off under the BC Energy Act. So trade-offs never really got a lot of momentum, however it does exist in there. And then the third way, one that we're seeing more and more builders go to, is you work with an energy advisor who analyzes your design and confirms your construction and associates what you're designing and what you do with an energy performance metric. So HOT 2000 is the program, EnerGuide is the rating system that we generally use for scorecards on that. And so as a builder, you can either do everything prescriptively, you're deemed to conform, or you can work with an energy advisor and do it based on a performance goal. You want to get to this level of performance, and it gives you a ton more leeway on how to approach the specific project you're dealing with, so that things that would be very expensive to follow prescriptively, you can do a little less on that, and then you can focus on the low-hanging fruit, because by doing something over here for little cost on your particular project for many reasons, would give you an equivalent benefit to putting something really expensive over here. So it allows your designer, be it yourself or your designer and you in the field, an awful lot of leeway, malleability, ability to look for the most efficient way to build. And what they're looking for is ultimately the same deliverable. What's the energy performance? So is that clear? Kind of that we had those 3 methods to go. Currently, the step code is available for communities, has been for over a year. It just depends on which authority having jurisdiction you're building under as to whether or not they've jumped into it and at what level. So if you're in a community where it has not been adopted officially, and there's lots of them, most of them at this point, you're just still doing what we learned how to do under 936 beginning in 2012 and refined it out in 2014 when the 936 became our guidance. The idea, the intent of the province is that they are encouraging the municipalities to jump in, but don't jump in with both feet. Come in at step 1 or 2, and let's kind of introduce ourselves into this process. And I tell you that the first significant thing you're going to see when you come out of 936 and jump into the step code is immediately you're working with an energy advisor, full stop. So a prescriptive approach and a trade-off approach is now really kind of gone, although doing it with an energy advisor you can trade all kinds of stuff off within, but it's still a performance-based approach. So as long as you get to the ideal, the goal in energy performance, you're deemed to conform. And at step 1, the actual energy goal is pretty consistent with what we're currently building under 936. They're pretty much built up. I was born and raised in the city of North Vancouver. There's not a lot of green space left for development out there, but there's sure a lot of crap houses on huge lots. And what they're looking to do is densify but they don't want to densify in ignorance of energy. So what they're doing is they're going to come in, when they pass through, they're going to come in as a mandatory lower level, step 1 or step 2 approach. But they're going to give you incentives if you shoot for the stars and go to, I believe, step 4 is where they're targeting right now. If you voluntarily go there, they'll let you put a conforming secondary suite on there. They'll let you put a laneway house in the back. They'll give you bigger FSR. So the extra pain and burn for going to a higher energy efficiency home, which really doesn't translate often into significantly more money, are people who buy our houses are really really greenvenient. They sort of want the most house for the least money at the end of the day. And it may be more energy efficient, but if you offer them 2 houses and one's cheaper but less energy efficient, which one do they buy? So we don't get rewarded right now so much for higher than minimum energy performance. We talk a mean line as a public, but we don't really show it except in some exceptions. So what they've done is they've incentivized builders and given them a financial carrot. Other communities are talking about fee baits. If you build to higher than minimum required for that municipality or that regional district, they'll forego your building permit fees, or. So they're trying to find a reason for you to push to higher energy efficiency. That way the deliverable of greater energy efficiency sooner in the jurisdiction becomes a truth. So there's I guess the beauty in a step code approach is it really does give control of the important regional direction for constituents, for members within that authority having jurisdiction, owners. It gives that local level of government a ton of control on where they're going to go, but it leaves the issue of how you get there, the minutiae of building completely, to the building code under the provincial purvey. City of Vancouver, it's very similar. You got a Vancouver building bylaw. They don't have a step code, but they jumped all the way to effective R22 right out of the chute. And in a nutshell, you're building at a sort of an advanced step 3 in the City of Vancouver if you're conforming with what their requirements are right now. So they went hard, but interestingly, with the step code, some communities, if they adopt or option the higher levels, may actually sneak past what the City of Vancouver is even doing right now. Greenest city on the planet, except for Maple Ridge. It's not, Maple Ridge is not going there, but it seems kind of interesting that the race is on. One other thing before we skip in and get into the details here that I think is really important is the National Building Code process in Canada took a look at this step code, a born in BC beast, and said, that's a hell of a good idea. And they are developing a step code alternate, might be housed even in the National Model Code, for the entire country. So this, like most other things in the last 2 major code cycles that we've seen, BC was first, fastest, and most significant in implementation on major thrusts like DAFs, like energy provisions, all of these things that have caused us to be here today, to look at how we can achieve these higher, loftier goals and still keep this stuff practical and consumer driven, and in my opinion, and most importantly, how to do it and not have another leaky condo crisis and oops. These unintended consequences is a huge thing, and when you go for high energy efficiency, one of the things you have to keep in mind is, by definition, you're significantly reducing the amount of energy that leaks out of your building in airflow and that conducts out of your building through conduction. And because this energy flow is so significantly reduced, in the old days, we built houses that worked by accident. If water gets into lightweight frame construction, we've had pretty crappy energy efficiency, and it basically means it cooked the water out. And if you want good evidence that that's true, think about the leaky condo. Yes, we reduced overhangs. Yes, we got sloppy with stucco techniques. Yes, we got really stucco with penetration detailing. There are a lot of things that I'm not going to deny. Horrible parapet details, terrible use of flashings and the second plane of protection. These are all real. I don't take anything away from those as being contributing. But think about what actually happened to that generation of 1980s built 4-story wood frame condos that was code driven. Leading into the code changes in the early 80s, we built with 2x4s and R12 or 14 bad insulation with little 2 mil poly, no tape. The codes leading into that generation where we switched gears and went to 4-story wood frame condos went to 2x6 wall construction, R20 bad insulation, 6 mil poly, it's incredibly vapor tight, and we taped it all up to improve air tightness. And then we face sealed the hell out of things, they got even more airtight. And what we got out of that was an actual substantial improvement in energy performance. The downside to that, of course, is it reduced the amount of energy that was flowing through old buildings. And if you think about it, how much of leaky condo was at the hands of energy efficiency? Most of the professional community dealing in building science right now consider that that's probably the single smoking gun. That's the one that had the most significant impact that caused us to go through 7 billion and counting in grief here in this province for renovations. So as we move forward and as we push the step code and as codes evolve moving forward, we better make damn sure that we're making choices that work. Because I will tell you right now, unequivocally, we don't have enough time today to prove it out, but I am absolutely happy to do so, or take our seminars, come do some of our hands-on training in our center, and we will show you that if you don't pay attention as you push energy efficiency forward, you will have failure. And that failure would not be a little bit, it'll be a lot, it'll be significant, and the resolution to that is going to be complete restoration at the magnitude of leaky condos. But it's going to hit houses too. And if you don't think leaky condo syndrome hasn't hit houses, it absolutely has. It's just who's the voice of single-family residents out there. There's no strata corporation. There's no council representing strata corporations. There's no minister responsible for single-family residential construction at that level that it exists for multi. So we want to be real careful. We want to pay attention. That I'm going to talk about the step code and the ideals, but I do not want to underestimate, and I want to end today by talking about why ICF is, in our opinion, and has always been in our opinion, a real sweet solution. And I get the privilege of lecturing internationally, certainly in huge volume across Canada, BC. I see everything from the coldest, remotest communities to the Lower Mainland and the South Island on a regular basis every year. And I will tell you right now that the Lower Mainland and South Island is one of the few markets in British Columbia that hasn't figured it out, that ICF is the way to go, not conventional basements. So we'll end today with some simple review of the building science, what we call the hydrothermal performance, and the reasons why basements and ICF construction in general, both below and above grade, offer so many significant advantages in terms of their durability and what they deliver. And in the long run, with energy efficiency going up and the demand on our construction going up, what we have to realize is that in the old days, the way we calculated thermal resistance in a wall, if you compared ICF to a 2x6 wall, they were deemed equal. About R20 and EPS foam equivalent if you just look at the R value of the foam, and R20 in theory bad insulation going into a 2x6 wall. But as you know, under 936 we now look for the effective rate, what is really being delivered for thermal blanket with the two construction methods. And when you take a look at an R20 bad, it's actually R19 because it's crushed half an inch when you install it. It's a 6-inch product in a 5.5 inch cavity. And it's interrupted with 27% or more of the area with R1 per inch wood. And when you balance that all out, it's actually an R16 wall effective with all the air films and everything else. ICF is 20, and it's still 20 because it's continuous. And you add the drywall, and you add the air films, and if it's above grade, you add cladding and other finishes. When you put all of that together, the number you were using is R24. It's a bit product specific, but it's sweetly in that R24 range in its basic form. And there's, because of the nature of the building science, you can just add more thickness to the outside. Now thermal massing becomes a reality, and that's something that an energy advisor can calculate its effect on. And so now your R value not only increases, but your net energy performance increases by the effective improvement in R values, and the fact that you get a thermal massing impact on there, which gives you the tempering of the highs and lows as temperatures go up and down, and that becomes quite a bit more energy efficient. And the other thing that we got to consider is, how airtight do you think this product is by the time you get 4, 6, 8 inches of concrete in the middle of it? It's naturally, spectacularly airtight. And being massive in nature, even if water did get in a little bit from time to time, what's it going to do to this? What's going to happen to EPS foam, the plastic webs, or the concrete that you stuff in the middle? Nothing. It's massive. So it's a very durable, naturally extremely airtight, continuous insulation system that has admirable building science. It's just brutally straight up. And I love how you compare the apples to apples approach. When you achieve the same thing, or try to achieve the same thing, even just looking at the basement, but this goes to walls above grade now too. By the time you get to the same level of energy performance with traditional stick build, you're probably paying more money than if you'd have just gone out of the chute and gone ICF right to the rafters. So when you go outside of BC, outside of the major demographic areas, you don't see a lot of formed foundations anymore. This is just absolutely the way to go. We see a continued uptake on things like the fast form, because you can actually monopore a wall and footing and not have ugly cold joints and pieces of 1x4 dunnage acting as super freeways for moisture outside to in. So when you start getting into remote BC, a lot of other things start playing in too, including that you can cast yourself a full foundation in one day that is basically in building science near perfect. So I don't want to make it a sales pitch, but I do want to underscore there's a big love affair in the engineering and the building science community for mass wall solutions with continuous insulation, and ICF is right in the sweet spot on all that. So energy code, it became our reality April 7th of 2017. As I said, it's going to be tweaked on us this December.
Just a quick comment, you mentioned on a monopore.
Yeah.
Those cleats would still stay in the monopore.
You leave everything in.
Yeah. So
but it's not a 1x4 dunnage holding your form together so you can pour everything in one shot. Every 24 inches in a single pour, which is not described in the building code. So it's not disallowed, but it's never spoken about. There's no direction in the building code on how to single pour a foundation and footing. What you end up with is 1x4 dunnage every 24 inches running right through that transition between your footing and your foundation wall.
that would be that applies here too.
In the monopore with the struts on it, or the bag form, it straps around everything.
We'll go through that in the afternoon.
Yeah. We'll see that. So there's a lot of things that I want you to pay attention to as we're building out here. Keep them in mind, and then think about how they're going to affect you as you go over the step code here moving forward. A lot of politically stuff here. The Building Act in British Columbia makes the building code actually law. They've declared for us that it's going to be consistent. There's going to be a renewed competency and innovation embraced in the BC Building Code. Chirp, 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 chirp. In December of 2017 was the end of local building requirements and bylaws, so nobody's had any trouble with the building official giving you some weird interpretations since last year, has it? The intent of regulatory reform, the intent of all these programs is to see a general migration towards a smoother, easier, more consolidated approach to administering building codes and building and designing under building codes. But everything takes time. But this is the chirp chirp from Victoria, and I do want to put it out there because when they say things, they're accountable to those things. And when they're accountable to those things, it allows us to hold their feet to the fire. It also is embracing new tools and opportunities, and we see that. Our new building code now has a prescriptive allowable section in it, for example, for exteriorly insulating finish systems, EIFS. Anybody here know what EIFS is? Well, it's back, and it's back and allowed in Part 9 with the channels as long as they're not less than 13% open and 9.5 millimeters deep. Is it good? I don't know. We're building a bunch of testing them because I don't think it's a trade-off for rain screen, but the code allows for it. So they are definitely looking at new tools, new opportunities, and embracing a greater cross-section of solutions. But in my opinion, mixed into our building code now is specific allowable approaches to some stuff that's a little bit scary hydrothermally, especially in a marine environment. It's mild, warm, and it rains a lot, and it doesn't dry out very long in between those events. That combination makes us hypersensitive, so I think we want to pay attention to that moving forward. Download it, read it. We have a climate leadership plan. In here is where they declare that we're going to be net zero ready for all new construction by 2032 in British Columbia. With the country now declaring that they're going to be there by 2030, I'd be interested to see if the BC government refines their approach to net zero ready or pulls those dates forward. And the reason I ask that is because BC has been first and foremost since, well, 2 codes ago at least. And they kind of covet that position, and then suddenly this puts them in second place behind the country. We may see even a shortening of that requirement to step 5. So net zero by 2032, an energy step code for local governments to implement. There's the control that we talked about, and they've refreshed the Climate Action Charter, which I've come to understand is saying, well, the old Climate Action Charter wasn't something that we did very good under, so we're going to change it so that we got a chance of maybe achieving it this time. In the old Climate Charter, did anybody read the part where we're going to have 100,000 solar roofs in British Columbia by 2020? 100,000 people would be preheating their hot water in British Columbia in 1 year from now. How many do you think we got in BC? I know of a dozen.
Yeah.
Right? There's not a chance. Solar thermal turns out in BC with our plumbing code, which requires double wall insulation from the glycol-charged solar thermal cycle and your potable water supply. Basically, by the time you get through all of that, you pay for those installations about the time they wear out. But you got to pay for all of that solar thermal up front.
Are they going to give any incentive?
Well,
Rebate?
why would you give an incentive or even have a rebate program on a technology that's destined to never make sense? So no, they won't. Where they're going to provide incentives, in my opinion, is in solar photovoltaic. Now that makes sense. And the price of that is coming down. And if you add an electric car to a house, you can pay that stuff off in 7-8 years now. So photovoltaic, absolutely. But, you know, they're not putting that stuff into the building code at this point. They just want the house to be built in a way so that if the owner chooses or the builder chooses to add renewable energy, that house is up to the challenge and will make the kind of energy savings equal to the energy consumption of that home year over year. Net zero, and you'll see it defined in here, is basically a house that over each 12-month cycle makes as much energy as it uses, or could if you added code limited maximum allowable renewable energy into the equation. You know, run a river? I don't know. I'm going through trying to get a privilege to tie in on the Ashnola River to put a little turbine system in for my cabin in the woods, and oh my God, I'm in year 5. I'm about $4,000 into the application, and I'm nowhere closer to the end than I was when I started. Yeah, I don't think we're going to see privileges for people with creeks in their backyard, and I've looked at wind generation, and even if it is good wind, you got to be 150 feet up in the air. Have you seen what a wind turbine tower looks like that can go 150 feet in the air? Like, no way people are going to put that in their backyard, or are the neighbors going to accept it, or anybody with view lots going to want to look through a bunch of 150 foot tall things. And really, wind is fun, but I don't see a future in there. It's going to be photovoltaic. When they talk about renewable energy in our careers, it's going to be PV. And I think realistically, we're going to see PV as an option that homeowners are going to move to as energy prices continue to escalate, and as we get more energy efficient with the home and they realize they can drive a second vehicle and pay nothing for fuel. Just fill it from their roof. So a lot of interesting things going on in the current state. We got a lot of programs for energy out there. Energy Star, the Passive House Institute has a Canadian standard for passive house. That is like net zero times crazy. I mean, that is super, super high energy efficiency. That's where when it gets cold in the house, you clap your hands together and rub them, and that warms it up. We're hearing rumors that the Canadian and the British Columbia political processes are looking at targets in that range for another 10 years down the road beyond 30. I'll tell you right now, that's a lofty goal. ASHRAE is a tool that we can use as design professionals, engineers, architects, and specialists who deal with predominantly mid and high-rise big boy buildings under Part 3. That's their tool that is very comparable to our 936. And when you compare them, they look very similar in how they're used and what they're concerned with, but the ASHRAE standards and the National Energy Code for Canada are really targeting larger structures. Part 3, 936 is intended to be our goal, or our rule book, if you will, for Part 9. So under 4 stories in less than 6,000-ish square feet in footprint over the lot. A lot of things that you find in a lot of these different programs, the old R2000, some of the new ones, is they muddy the waters between energy efficiency and environmental sensitivity. I've done a lot of lecturing, I see a lot of familiar faces in here. I don't want to go too far into proving this out, but you can make some tremendously smart energy efficiency decisions that are horrible for the environment. I mean, case in point, British Columbia, just quickly, changing over from an old tungsten filament conventional light bulb into compact fluorescent. So when you put electricity into an old light bulb, you get 2 things predominantly out of it. Light, which uses almost none of the electricity, and the other thing that comes out of an old light bulb is heat. Right. But what's interesting is, because it's fueled by electricity, at what efficiency does it produce heat? 100% efficiency. That's the beauty of electric-driven heat. If it's producing heat, it's doing so by definition at 100% efficiency. Otherwise, it's just not using energy. Or it's using energy for something else, like light or kinetic motion or whatever. But if it's heat coming out of it, it does so at 100% efficiency. Now, when you take all of those 100% efficient electric heaters out of a house, now consider for a moment, what's the green carbon footprint of electricity in British Columbia?
0.
Well, it's 97% absolutely clean. We run a little bit of diesel in remote communities, which is kind of outside the argument I'm making here anyway. And we do have Burrard Thermal, so when we brown out on Christmas Day and don't have quite enough power for the grid, they fire up some of those natural gas turbines over there.
Shut that down.
Oh, I think it's still there for emergencies.
Mm-hmm. Oh, I didn't know
Yeah, yeah, they like filming over there whenever it fires up because it looks like a Russian nuclear plant. But if it shut down, I didn't know about that, but I don't know how they're making up for the losses in their grid.
It costs too much to redo the boilers or something.
Well, just tell people, oops, sorry, you can't cook your turkey at Christmas.
Yeah.
That wouldn't fly too much when you're pushing Site C and everything else. It's probably slated to disappear if and when Site C comes online, which looks like it's going to complete and be a reality here. So when we factor in air-conditioned, tempered homes in every community in Canada, and by we I mean CMHC in an independent study, compact fluorescent bulbs make no economic sense in any community anywhere in Canada. Just on the energy demand. Now, what's in a compact fluorescent bulb that's not in a tungsten filament? Mercury. They put a drop of mercury in each and every one, and then when you turn it on, it actually instantly vaporizes that by driving huge electric potential through it, and it vaporizes into mercury vapor. So every time we smash one of those, what are we putting into our environment? One of the worst heavy metal contaminants we know. So is this a really good, healthy green choice? So then you would ask, why would our electrical utilities promote it?
They don't have enough energy.
Well, they've got lots of energy, but we don't pay enough for it. They can sell it for twice as much to just about anybody else than what they sell it to us residentially. And they push and push and push to try to get those rates up. We're what? I pay an average of 11.8 cents a kilowatt hour. We're in second tier at my house with 2 women. We're in there about noon on the first day. But I take my bill and divide it by kilowatt hours, and I average year over year 11.8 cents a kilowatt hour. I can buy natural gas, however, in a kilowatt hour, I pay about just under 3 cents a kilowatt hour for that. So at the end of the day, if I want to save money, I do want to burn more fuel in my furnaces. And I'm really compelled to not make green choices here in British Columbia because I'm chasing the cheaper fuel, even with carbon taxes and everything else. So there's a lot of interesting stuff that goes on, and I haven't even touched on some of the other challenges. If you look at LEED and Built Green programs, they balance energy efficiency with doing things that are good for Mother Nature as well, and you get points for this, and the combination of that gives you your labeling. It's important to understand that 936 and the STEP code and the legal jurisdiction of the federal and provincial code only relates to energy, not the environment. So when we talk about energy efficiency and chasing 936 and a STEP code and all of these things that are in our building codes provincially and nationally, we are not driven by an underlying conscience for the environment. We are being driven specifically to reduce the consumption of energy, and there's nothing suggesting that we're driving that consumption to a greener energy source. A lot of pressure for us to burn more natural gas. So I commend that we have programs like Lead for Houses and Build Green under CHBA. These are important, but they aren't all energy programs. So they will have a role moving forward, but their role will be that at the baseline they meet a certain energy performance criteria that matches to a STEP code, but beyond that you're doing something good for Mother Nature. And that'll be for those few but very real consumer out there who have the money and are quite green vested. They're willing to pay extra money to do the right thing by Mother Nature. And there are builders who concentrate their practice on that. And when you look at the green footprints of these products, and you look at foam plastics in an expanded format versus extruded or foamed in place or polyisocyanurates, which are just... When you look at those products, this stuff greens pretty nicely. It does come from an oil derrick, but then it's steamed into a sort of a big Rice Krispie treat, pressed into its compressed formats, and then put into these wonderful shapes that we can then use as leave behind forms which dual purpose and bring efficiency and fantastic building science to construction. So there's, I guess, a lot of things for us to think about. At the end of the day, remember, this is all, the conversation for the STEP code is all driven towards energy efficiency. Everybody wanted to get their name in here. Apparently all of these groups were spoken to. I'm a member of Canadian Home Builders and GBHBA. I do personal or professional consulting for the province in the Homeowner Protection Office. I sit on the national task groups for many of the Part 9 code elements that we deal with here. I consult into Hydro and I consult into Formus, but nobody even picked up the phone and called me about the STEP code when it was being developed. There's a lot of people that want to talk about how, you know, the government is inclusive and they're putting everybody in here. Look at the bottom, professionals and trades. How many people in here got a phone call, letter, or anything on the development of the STEP code when it was being proposed? How many people heard about it first when it became a requirement last year in 17? Or just becoming aware now? So, you know, I don't want to pick too much on the government here, but their outreach is pretty shitty. Energy STEP code. Here's what you do right now. Step 0, if you want to call it that. If your community hasn't adopted yet, many of them are in this position here, then you're just bound by 936 and you can do prescriptive trade-offs or you can do energy model with an energy advisor. Obviously it's going to hit the level on average across all the climate zones here that we're averaging right now. So there's no net improvement to doing what we're already doing and continuing to do it. When you go to step 1, a lot of people have said, well, what does this mean? What are we going to be delivering at the end of the day? Well, what you are going to be doing is abandoning prescription and trade-off. You're going to be working with an energy advisor, and in the politically softened language, they say the energy expectation there is improved. I don't know, because it doesn't improve it in any metric that we measured. It just firmly establishes that we're working with energy advisors and achieving the minimum requirements expected under 936. Where we start to begin to see change is when they adopt into step 2. And you know, I'm not belittling step 1. If you're a community and you want to jump in and you're scared about changing the nature in construction, going to step 1 just gets everybody used to working with an energy advisor, creating those habits in design and construction, and that's actually going to be half of the challenge for most of us through all this whole step code. Learning to trust and engaging quality energy advisors who know what the hell they're doing and know what options are available out there and can help you research and develop the choices you're going to make. Here's a caution I put out to you. We just took, and this is not a dig, we just took our warehouse girl who worked at Safeway and we jammed her into the Energuide Advisor program. in May, and she's now an Energy Guide Qualified National Certified Energy Professional. And we've piled her up with the door feds and everything else, and oh my God, she's been crash coursing in building science and everything else, but in her own words, I'm not doing this without you overlooking all the files. And we offer a very comprehensive service beyond energy. We'll give you the energy advisor, but we'll help you figure out what you want to build, how you're going to build it, what the hydrothermal risks are about that, where the cost advantages are, tricks, trades, all that kind of stuff. But working with an energy advisor, jumping in at step one, as soon as everybody's in this situation, how easy is it going to be to find an energy advisor 2 and 3 years from now? So if you're not working with one right now, strong suggestion, lock it up. Get somebody who you can work with, who you trust, who's reliable, who's professional, who has experience that satisfies your needs, and pay them what they're asking, and let's get used to it. How easy is it right now to find somebody to put siding on a house? Imagine what it's going to be like when everybody's jumped onto the step code. What happens when the provincial government, because right now they're encouraging municipalities to jump in, what's the history of government? They give you incentives and encouragement to do something, and then a year later, what usually happens? They make it law, and all the money goes away, and all the freedom goes away, and you just have to do it. So reading between the lines, all your communities in BC, I think you can reliably expect are going to be somewhere in the step code in the next 18 months, maybe less. At step 2, which is consistent with sort of Energy Star as a program, what you would gain if you subscribe to an Energy Star project, is about 10% better in energy performance than what you have right now. And then moving through to 3, you're starting to align yourself with the highest level of Built Green program, the CHBA program for energy and sustainability. And you can see that's actually a marked improvement, 20% energy performance improvement. That's real, like that's measurable. That's if you're just doing it in money, the money you're spending on energy you would expect will go down by 20% if everything else kept level. I will also suggest, if we were only going to step 3 and building to that level, you could do what you do today and you'd probably be okay. You just need more insulation in the wall. So you go from R20 to R22 to R24. You'd push your R values in your attics up, and you'd push your R value below grade up substantively over where we were in the past. By doing that, getting air tightness under wraps, you could continue to build the way you are right now. And hydrothermally, the risks are probably not that much greater. But beginning at step 4 and 5 and beyond, something weird starts happening. You continue to build basements the way we do, conventionally, with studs and pink and poly on the inside, and they will just fail. If you continue to build walls out of 2x6 and try and stuff more R value into that cavity, you'll reach a limit far short of step 4 or 5 or beyond. And if you continue to vent conventional attic spaces, they're all going to go moldy on you. It's just night sky cooling. Lots of studies on it. We know this. We have houses right now that work by accident because of that energy flow. And when we take it away, these are the symptoms. Basements and walls and attics, the way we currently build, stop working. So as we move towards step 4, and certainly when we make the quantum leap into step 5, you will be building different houses. So my message that I believe is the most important takeaway from this, if nothing else leaves here with you, is you have a choice in this industry as a professional, as a builder, as a supplier, as a manufacturer, as anything. The most efficient thing you can do right now is find an energy advisor group that you can rely on to grow with, and make a very significant effort right now to figure out what changes you're going to make to your methods in construction for basements, walls, and attics. So what I'm saying here is, I could sneak out with 2x6 for you to about this level. Once you go to this level, the old R2000 level, I can't do it for you with a 2x6 wall and a conventional vented attic. They just don't work anymore. Too little energy flow through the envelope to reliably get reasonable performance. And that's exaggerated in the marine environment. So you're soaking in one of the toughest environments to build high energy. And the irony is, the reward for high energy efficiency in our environment is the least of Canada, because our heating degree days are sub 3,000. The rest of Canada is way north of 3,000 heating degree days. So we get the least advantage for energy efficiency, and we incur the greatest risk. So If you're working in 5 communities right now, and how many of you are doing City of Vancouver, Surrey, Tri-Cities, Burnaby, and Aldergrove? Something like that, or 2 of those even. What are you going to do if one's at step 0, one's at step 1, one's at step 2, one's at step 3, one's at step 4, one's at step 5?
That's my question. Is it mandatory to take step 1, everybody? Are we back to municipalities where I gotta go Burnaby? Oh, you're at 2, you guys are at 3, 1. Is there a minimum, first of all? 1?
No, the minimum is if they don't adopt anything, it's 0, it's status quo under 936. So what I'm suggesting you could do is research a way that you could alter the way you build roofs and walls and basements now, and keep the intensity, the energy intensity that low by using minimal blocks, minimal insulation, achieving air tightness through greater detailing, getting rid of vented attics, moving towards a system where you don't have to get fatter and fatter and fatter with that wall, because the penalties there are huge. Eats up FSR, very inefficient to use fluffy insulation when it's getting fatter and fatter, and it gets colder and colder on the outside, so it risks more and more failure. What you want to do is you want to take a look at all your different options. What about ICF all the way up to the rafter? The stuff's crazy good basement, but it's crazy good hydrothermal performance above, and at R24 effective, you're already past City of Vancouver. And then, by building into this at a minimal, yes, you're overshooting steps 2 and 3, but you're learning how to work with these products.
So if we go to that code right now, we're doing our own codes. So when I go to Langley, they say, hey, nice job. And then Burnaby says, hey, you guys are really, you have to do this. And Langley says, hey, wow, you guys are doing a great job. We're only at step 1, you're at step 3.
And you're achieving step 3. Well, mind you could keep your attics lighter in value, and you could switch over to a conditioned attic instead of unconditioned, and you could move all your mechanical, if you got a full basement, can now go up into that attic, and you don't have to insulate all the ducting when you push that all up. And so now these changes in construction type allow other freedoms in design, which actually make construction, even though you're overshooting step 0 or 1, may make it still competitive. And in fact, I can show you, it for sure keeps you competitive, even against other people doing a 2x6 with a vented attic and a garbage basement.
It's going to come up to the builder then who wants to do that and get ahead of these guys. I'm going to determine not the Langley or Burnaby.
You're taking control. Now, let me add one more thing. If you get good at that, then what's the only thing that changes marginally from jurisdiction to jurisdiction? The block or the exterior width on the outer withe, or adding more insulation to the outer withe of this. With your attic, it's just more insulation in that conditioned format. For air tightness, it's just a greater attention to detail at your detail transition so that you can gain that air tightness. But the skill sets for you, your subtrades, your supply chain, everything remain unimpacted as you progress through here. If you don't, you want to sneak this out, you may have to relearn how to build twice, at least, through the step code. Who wants to go through that? It's crazy.
So Mark, if you go to a conditioned attic,
Yeah.
what material would you use for insulation that doesn't require?
It's got to be airtight. That's the condition by which you have to achieve.
SIPs or something like that?
SIPs will work. SIPs works better with a vapor open peel and stick. When we go up north, that's where the failure is in SIPs, is at the joints. So we foam the joints, but we cover everything with a vapor permeable peel and stick second plane of protection. It's awesome. 2-pound foam, amazing. With some contingencies.
You can't use that.
Yeah, you can. 2 pound is absolutely part 9. It's half pound. That isn't reference. You need an equivalency for opens.
Well, what they say is you can't see leaks in the potential.
Who's they?
City of Vancouver.
Yeah, the City of Vancouver is under its own bylaw, and they have their own provisions. And what's ironic is they had a beautiful way of accepting foam just before Tim Rice and Dave Ramsley left. So I don't want to talk about the City of Vancouver too much in there. When they say no, they say no. But you know, next week we've got Chris and all the people coming over from the City of Vancouver. We're showing them conditioned attic approaches and why they work.
I think it's an idea that time has come.
It absolutely is. Let me reinforce that concept. 20 years ago, 30 years ago, how did you build a crawl space if you were building a crawl space?
Insulation.
You put the insulation, air tightness and everything up on the floor and you vented the crawl space. How do you build crawl spaces now? Anybody building that way?
Insulate the walls.
You insulate the walls, you created air tightness, and your envelope now becomes the slab, the walls, and the continuation on your envelope. When did the code change that took us from vented crawl spaces to conditioned crawl spaces?
2006.
No.
Early.
No. It didn't change. You're still allowed to do both.
I don't see it the other way now.
It was the builders that took us there. The builders took us there because they were putting in a crawl space home, they were forced to use a square footage on the main for mechanical room. And then some builder looked and said, if I condition that crawl space, and I talk to the mechanical community and they build me crap that works in a 4-foot clearance, I can stick it all under the stairs and in the crawl space, and now I can sell square footage that is a mechanical room on my main. And when they ran the numbers on that, it paid for the whole transition.
That's everywhere up country.
Everywhere, right? Now, we're faced with the reality that a lot of people are completing basements or leaving unfinished basements. And when you get up north to build a crawl space, you actually have to dig a basement and then backfill it. So they just leave unfinished basements in there. But if you do that, then where do you put the mechanical? But if you condition the attic by taking insulation and air tightness off the ceiling and push it up, what can you stick in your attic now? Everything. And when you run ducting through there so that you can run all your service, and in air conditioning you're dropping heavy air down so you don't have to overstress your AC or heat pumps or anything. You can put high side returns in there for great circulation. It's just cheaper, faster, better. And it's all stuffed up in that conditioned attic. You got a lot of money. And think about your ceiling now. What kind of pot lights and everything are you putting through the ceiling? Regular. Because your envelope's up. The key is got to be airtight. Got to be airtight, and that's why the foam plastics, in place or SIPs are really good choices. You're free to play with ICF. I don't know if you're allowed to span it on a sloped roof, but that'd be kind of cool. And then when we get to step 5, basically they're saying net zero ready. They're not even talking. Some people are throwing numbers around of 80% better. We've run some numbers on step 5. There's every likelihood that it could be 100% or better energy performance than what we're dealing with right now. How's our time doing here, Joe? Okay? What time's lunch coming? And
You got 40 minutes?
perfect, exactly what we need. So what we need to do is when we look at the step code, we understand we're going to be working with energy advisors. For step 1, 2, and 3, you're going to be working with certified energy advisors. I think they got a different name for them now at Energy. Yeah. Everybody needs new business cards in government every 2 months and new names. But what an energy advisor does is they go in and they look at all the metrics. Window performance, solar heating. So they need to know what way your windows are facing, how you're oriented on site. They look at the effective R values of all of your different systems below, above grade, and in your attics. They incorporate in there a door fan test to determine overall system air tightness. So they measure that as air changes per hour at 50 pascals. So there's physical tests that go on. There's visual confirmations after design to confirm that you built what you said you were going to build. The amendments between design and construction are altered into the original performance file. And at the end, they issue an as-built equivalent energy profile. And it comes up with one simple metric. It comes up with the amount of kilowatt hours of energy in all forms that home will burn every 12 months based on the energy performance you achieved with all of that radiant energy, conductive energy, convective energy through air tightness, window glazing, fenestration performance, all the stuff that affects it, insulation, conductive resistance, all of the things that go in there. So I guess the nice thing about working with an energy advisor is things can kind of simplify for us as designers and builders because we're relying on professionals to do it. But remember, an energy advisor is not motivated to give you the cheapest, most cost-effective way to do something. They're motivated to get you your energy file. That's where experience with an energy advisor becomes important. Because if they've seen a million solutions, you can what if them. What if we do this? Do we still get our energy? Yeah. And then you as a builder can say, yeah, and I know I can get better supply rates on this kind of a construction method than I can on that, or I'm paying way too much for site labor right now, so I'm going to look for something that's more factory developed, SIPs or ICF, taking a ton of the labor out in the traditional forming that goes on with foundations. So you look at your business, which only you know, and you look at what impacts your profitability, which only you are going to be familiar with for your specific situation. You work with an energy advisor and you're smart if you know how to what if them. If I do this, what's the consequence? If I do this, if I do this, if I do this. If I do this, is it going to make it? I mean, that conversation, that dialogue is going to be how you attend to energy efficiency the right way moving forward. So instead of just digging into a building code and assuming you know what the hell it says, and it's confusing language, trust me. I'm involved in the writing of it, and you have no idea how long it takes for every word that they put in there and the million meanings they try and put into each and every sentence that they create. It becomes more of a conversation between professionals, and good decisions come from that. And over that, the big halo that I'm putting on everything here is I plead with you, learn early and practice early your changes in construction that are going to take you all the way through step 5 and beyond. Make the change once. Use the opportunity where you don't have to get to step 3 to hone your skills to be able to deliver step 3. And then when you're competing against people who are just chasing the minutia of a change from 1 to 2 to 3 to 4 to 5, you're going to be able to outcompete them on their home turf, and you're going to have all of your guys, all of your suppliers ready to hit any level in any community that you now pull up and work in. So I strongly suggest the takeaway from here is make your choice now on what the new form in construction is that's going to make sense. And that's why when the guys asked me to come here and talk about ICF, you've heard me speak for, believe it or not, 30 years. I incorporated 30 years 3 days ago. Yeah, not bad, huh? So steps 1 through 3 are arguably 4. You'll be able to work with your energy advisor. By the time you get to the upper level, things start moving over to simply achieving conformance with metrics. Once you get up into high energy efficiency, there's so many combinations and permutations, and energy modeling sort of loses a lot of its reality, because at the end of the day you can use an all-in, all-out kind of approach. So TEDI is something I want you to get used to. TEDI is, I think I've defined it for you. It'll come to it. TEDI is total energy something index. What it basically talks about is how many kilowatt hours of energy are you going to use per day. And in its purest form, that's what an energy advisor does for you. But you'll be able to develop those metrics based on systems approaches when you're in the higher levels. And as long as you can show that the overall TEDI performance of that house is within the target goals, it's deemed to conform. So your energy support through energy advisors will go away from HOT 2000 and programmed responses. It'll just go into pure calculation of metrics. So mechanical engineers or new generation energy advisors are going to be able to produce that metric for you. The other one that they've got in there is a peak thermal load PTL. This metric's kind of interesting. It sort of runs on the theory that if you build a house and you limit the biggest size available for heating and cooling in a home to X amount of kilowatt hours of generation, so it's you only have this big furnace or furnace and cooling and heat pump, then you're going to be forced to build the house around it that maintains 12-month comfort. The problem that they find is this creates a fantastic disparity between archetypes of homes. Basically, using this peak thermal load, you can get away with murder on large small houses in mild places, and it'll kill you trying to achieve a peak thermal load metric when you're up north building a small, tight, energy efficient home. So it didn't really end up achieving what they hoped for. So in your first step code provisions as they exist in 2017, they talked about it and they confirmed for the upper step levels that we're going to be using these thermal energy demand intensities and these peak thermal intensity metrics. Well, as of this December, they're nuking PTL, and they're altering TEDI and MUI because there's some other things that happen. I don't want to get too far into these metrics. Think of them as a speedometer for a house. They're a rate of flow of energy measure. So if you got a house that's only allowing really slow energy flow through it net over all of the places where that happens, it's really energy efficient. If it's just racing through your building enclosure in one or more places, it's not very energy efficient. So these are just speedometers or metrics that help us determine whether we're getting where we need to go or not. So as of December, when they solidify the minister's signature and it comes into effect, that PTL, peak thermal load metric, is going to disappear for us, and you're going to see tweaks on a table that talk about different marginal goal posts shifting for TEDI and MUI, the mechanical energy use intensity and the total energy demand intensity metrics. So really don't need to know a ton about those right now, other than eventually when we get to step 4 and 5, these are going to be the way that we measure things. For now, it's just going to be how many kilowatt hours per year is the estimated fuel utilization on a home, and it's going to be, in all instances, it's going to be some form of an energy advisor doing that work for you. Considers everything: losses, air tightness, insulation, gain, solar gain, people and equipment. Why Teddy became really interesting is here in British Columbia about 7 years ago, RDH and Morrison Hirschfield, in conjunction with myself and a few others, we got a commissioning from the government who wanted to look at the possibility of metrics as opposed to computer modeling. And one of the reasons I want to do that is because HOT 2000 is a federal program using federally produced and managed software, and the province has no control of it. So if we codify that you got to use HOT 2000, what happens if the federal government just cancels it? Then you can't build a house. So they want to wean off of HOT 2000, they just can't do it yet. So when we did that, they said, you know, there's a couple things. We want to know if this metric makes sense, and we want you to apply it to a demographic we don't think is doing very well for energy. And that was mid-rise glass tower residential in BC. And what we did is we did, Teddy, by taking the total energy that was consumed by these mid and high-rise towers, and then we broke apart every single component of that building and ran significant testing. We have these interesting little things that give you an R value for an assembly anywhere on a building that you place it. And so we did it theoretically, we confirmed it in the field with these beautiful energy flow devices that we have. We use these cool things that zap the argon gas and determine what fill level is left in sealed IGUs. And we accounted for every single milliwatt of energy that was flowing out through the enclosure. And we accounted for every milliwatt of energy that was going to heating pools and everything else. And what we did is we did whole building air tightness, and we took the total amount of energy that went in, took out all the things that we could explain, and what we were left over with was losses that were literally slipping through the cracks. So now we knew intensely accurate numbers on how good the windows, the walls, and the slabs, and the basements, and everything else were performing. We had quantified exactly what the air tightness of that building was, and we accounted for all the other energy that we used for running elevators and everything else. And the difference between that and the total amount of energy coming into the building is the energy that's lost in the cracks between window and wall and slab. All the places we call the chi losses. And when we added that all together and equated it back to a net effective R value, what do you think the average 16-story mid-rise residential tower in British Columbia built between 2000 and 2010, what do you think the average R value was for the entire building envelope?
R4.
4, it's a good guess. It's pretty pessimistic though, right?
What's the windows?
R8.
It's the windows.
Yeah, windows are a pain, right? Any other guesses? You have to round up, and you have to actually round up and use significant figures to get it to 2. It was high ones.
Yeah.
That's the net energy performance we're getting and all that crap. Pretty scary, huh? What's really scary is those are all done with mechanical engineers applying ASHRAE at the time. So guess who got a talking to? And found there were a lot of holes in ASHRAE that were allowing that kind of performance, which was not the anticipated metric that we would get from it. So there's been a lot of stuff that we've done, and basically the heroes in energy so far have been our houses. They suck, but they suck a lot less than R2. When we're finished with all this stuff, the net effective R values at step 5 are going to be, in a really barbaric sense, like measuring earthquakes by Richter. But you're going to be getting net average energy performance that, if you equate it back to an R value, is in the R30 range on average around the enclosure. Right now, you're building at 16. So there's the number that I'm suggesting. We're going to be 2x or more even in the cold parts. So these metrics are coming. The energy ERS, or the MUI's Mechanical Energy Use Index. What that equates to is you look at all of the mechanical stuff in there, not the peak demand. So on the coldest day, what's the smallest furnace that can keep this comfortable? That's that PTL metric. What this is it looks at all the mechanical devices, HRVs, air conditioning, heat pumps, furnaces, in-floor with boilers, anything that's contributing mechanical energy into the home. And we look at this mechanical energy utilization index as a general indication of the performance of the home. And that MUI index actually does a pretty good job too. The only problem with it is, how often when you're speccing a furnace do you talk to a mechanical supplier and you ask them, well, what size furnace are you going to put in there? and the first thing they do is check their warehouse and see what they got a stack of. Are they really doing an energy loss calculation before they size that? Are they considering the efforts that you're putting in to designing and building your home? So if we're going to use MUI, we have to pay particular attention to the fact that the mechanical systems are going to go through a fair amount of scrutiny in the energy advisor's hands, because they will have an energy loss calculation as part of HOT 2000, and they will determine that no, you don't need a 4-ton unit in here, you can do it with a 3-ton unit. I have one other question too. When we put fans in for exhaust, 932, etc., which has a direct impact on energy performance, who do we usually trust to install the fans?
Carpenter.
Electrician.
Electrician. And what do you think the electrician does so that he makes as much money as possible on fans?
Does it as quickly as possible.
As quickly as possible, and what does he buy? One at a time? Or does he buy a truckload for the best deal he can get? And so when you spec a certain ventilation rate and you hand it over and you give it to your electrician and they punch a hole in the ceiling through your air barrier, what are the chances you get in the right fan and they're not screwing up your air barrier?
Slim and none.
Right? So as we move forward, the builder's job is going to become one of developing and managing your approach in construction that minimizes some of those nightmares. You want to take back control and ensure that the fans that are going in are right-sized and that energy recovery units are installed so they can be managed, maintained, or proper sized, and that you're passing on the maintenance requirements to the homeowner, because an HRV is a waste of money if you're not cleaning out the filters, etc. So our job as builders is simply going to become more knowledgeable about what it is we're doing and become very good businessmen with it. And we're going to have other generals working in our camp with energy advisors. As long as we hire the good ones, we should be able to wage some pretty impressive campaigns. And in the background, use services like Van ICF and ourselves, who have spent a ton of dough putting square footage into committed training. You can come into our place and we'll give you a 10-foot blank wall in whatever it is you want to build, and it will have 4 windows, a door, a dryer vent, an electrical penetration, a hose bib, an alcove, a roof transition, a rim joist, an attached ledger, all on one 10-foot by 10-foot wall. And bring all your guys, bring your sub-trades, plug them in, get them to build that over 3 days, and then we'll test it at the end so that we can show you what's going on. Who here's taken our window and door installation course? Anybody? People come out of there like they've just had a religious experience. And then the next thing you know, they've got their CPDs, but they're booking out 6 of their guys. Just go in there, tell them we want box frame, blah, blah, windows, and I want you to come out of there knowing damn well how to put them in. And what's really fun is we'll show you how to put windows and doors in way faster and way cheaper than you're currently doing it. And so that they don't screw up in 20 years. So there's a lot of really good information. But building in this new environment is going to require more education. That's why my wife and I have sunk so much time into it. That's why your ethical, committed, devoted suppliers out there are absolutely devoted and committed to making sure that you're getting good knowledge and understand how to use their products properly. Like, I'm sure you guys are not interested in somebody using ICF and having a bad experience, right? So knowledge is the only thing missing between having a good experience with ICF and a bad. How do you consolidate it? What's the load? All the stuff we'll deal with this afternoon back here. So as we move through, understand that the step code roadmap is to try and get us to this net zero ready by 2032, and don't be surprised if that tightens. And if we take a look at conformance under step 1, basically energy modeling is required at step 1. You're required to test your air tightness and report it. You don't have to meet a certain minimum level. Your path for conformance is using the BC Building Code under 936.5, which is the performance path. And you can also, as a backup to that, you shouldn't really say or, because at the heart and soul of 936.5 is your energy advisor is going to give you an EnerGuide rating score based on their HOT 2000 software version 15, based on a reference house. So they'll take your house, theoretically build it to the minimum of 936, then they'll remodel it based on how you're proposing to build it, and they'll compare the two. And so you're allowed to do whatever you want as long as it makes the code if you'd have done it without tweaking it out. So you can suddenly build a log house with crappy logs for R value by reducing glazing area and making the thing even more airtight and over-insulating attics and basements. So this is actually allowing us to explore tons of new freedoms that we didn't have under the limits of prescriptive. Dream it, probably a way we can build it. Give me enough money, I'll figure out a way to build anything, but doing it cost effectively is something we want to watch for. So that's step one. You must model it. You must air tightness test, but you don't need to achieve a score. You're basically following the performance path at 936.5, and you're going to report the metrics. But you're not going to be reporting that PTL, because as of this December, we found out that metric is just really, that peak thermal load thing is not doing what we need it to do. So you will be doing your thermal energy demand index. That metric will be reported by your energy advisor. And the reason they want to report that in air tightness is information gathering. They want to see, as we move through the step code, what are we actually achieving, and then we can start to further refine the expectations. Uncover certain archetypes of homes that we didn't consider that maybe are being treated unfairly at these different step levels, and bring things back into measure for them. These changes we see this December are the first round of that. Fine-tuning to take advantage of the fact that not all houses are created equal. Even in the same energy zone, zone 4 or 5 or 6 or 7A, B or 8, you know, even within that unique zone, two different types of houses are going to have two different energy performance under the same regime. So they're trying to create it so it's very balanced and that you get the same reasonable, comparable energy results no matter what kind of building you put together or what zone you're in. Once you go to step 2, you are now working with your energy modeler, but you have to get to 3 air changes an hour at 50 pascals. Does anybody know what the average air tightness was over 100% of all homes built in the city of Vancouver between 2005 and 2008?
1.8, 2.4.
As an ACH 50, the average air tightness was actually over 6. Horrible.
We're talking about ELA.
I'm talking about, that's air changes per hour measured at 50 pascals. The volumetric use that we use in part 9. It's not equivalent leakage area. That's a metric that we can spit from that in HOT 2000, but they use the air changes per hour metric measured at 50 pascals. 6, which equates to a hole through the building envelope if you add all the little ones together at about the size of a manhole cover. To get down to 3, you got to get down to about this big. We're currently building a little bit better, but we're still in the 4 or 5 range, ACH 50. Much better in the cold parts of BC and Canada, but that's because if you've ever spent a winter in, say, St. Gregor in Saskatchewan and the winter wind is blowing at 35 below, you feel air barrier problems right through your bones. They chill you. Shockingly, they have built, even as early as the year 2000 on average in Saskatoon, the CMHC files show that they were building at an average of 2 air changes an hour at 50. 1.6 is net zero. And what is it, 1 or is it 0.6? 0.6 I think is passive house. That's crazy, right? You slam the door and your ears pop. Mechanical energy use is one of the metrics, so you're allowed, it's going to result in a 10% better building energy-wise than what you're doing right now. You use your EnerGuide rating system against a reference house, or if you want to, you can just have the mechanical energy use index, the new adjusted level for MUI, and that metric will give you code conformance under the step code at step 2. And then under the building envelope, you can use your total thermal energy demand intensity. That metric's been tweaked around a little bit too, and they've eliminated the peak thermal load PTL, so ignore that metric at the bottom in there. At the end of the day, what I'm saying is, look at those. These are kilowatt hours, so it's a measure of energy in time. You use 1 kilowatt per hour. Every day you're burning 24 kilowatt hours, right? So what that is how many kilowatt hours per square meter of enclosure per year you're using is where these intensities come from. So step 2, about a 10% better. You can see your full-on door fan testing, full-on, and you get introduced into using metrics. By the time you go to step 3, you're tightening up to 2.5. This is probably the best in BC. You're building in the 1.5 to 2.5 range Certainly people out there getting into passive house levels, but that's an extraordinary level of attention to detail for air tightness. But if you deliver on the energy model targets on here, basically it's got to be 20% better than a 936 current conforming home, reference home, adjudicated by an EnerGuide specialist who would reference your home if you built it by 936 and then models your home the way you're going to do it. You got to come 20% better than that. Or in the alternate, you just use a mechanical energy use index, make sure that you add it below the metric on a square meter basis of envelope, and you're deemed to conform. And the building envelope itself, no matter which metric you go with, once you start into step 2, 3, 4, and beyond, you have to report your TEDIs, and those TEDIs have to make the threshold maximum allowables for those different levels. So from here, it just basically beefs stuff up. There is one noticeable change. When we get into step 4 here, you can see you're still using an EnerGuide rating system, version 15, HOT 2000, certified energy advisor, or you're going into a much tighter MUI and a much tighter TEDI. You're also dropping down into some pretty significant air tightness requirements in here, but you're also delivering 40% better energy efficiency than what you're dealing with right now. And then when we make that final step, sometime between now and 2032, and in some communities it'll be much sooner than 2032. Yes, you got an energy model. Yes, you got a crazy air tightness level you got to get to, 1 flat. Yes, you got a very, very miserly mechanical energy use intensity number. You're only allowed 25 kilowatt hours per square meter per year of enclosure. You don't have an EnerGuide ratings option anymore. So you'll be working with an energy advisor, and you will be modeling, but you're just modeling to that metric. So you see now the intent to phase out the reliance on the federal government HOT 2000 program, and we're looking at the transitioning of the energy consulting industry into the new world order of just dealing with metrics, something that the federal government can't ever take away. In addition, and as the backup to your mechanical energy use intensity, you're going to do the thermal energy demand intensity. That sort of gives you an idea, the total energy demand intensity sort of gives you an idea of a well-developed designed home. You balance all of the mechanical, you ensure it's going to deliver 100% comfort in there, and it's going to do so under an allowable threshold of 15 kilowatt hours. In addition, you got the mechanical energy use intensity, which is a much more, how big is your furnace, how big does it have to be to maintain that energy efficiency across. So those metrics exist, and again, the peak thermal load one is just going to disappear. That, in a nutshell, is your step code, and the tweaks to the step code are what I talked about. If you want good information on this, and it is revised and ready for print when the minister signs the new changes and amendments, there is an updated version coming of a free document you can download from BC Housing. It's put together by Graham and the guys over at RDH. I reviewed everything that's in there. It's a pretty nice little summary document of how to achieve 936 and how that overlays with the step code requirements and demands there. So there's some good publications for that.
There's all these variables going into the construction process. How can we prove code compliance in the life span of the house, like in year 2, year 5, year 9? Because I work for the warranty company, and of course we have to pay off if it doesn't meet code.
I'm cheering right now. So if I can summarize the question and understand it correctly, what you're asking is, sure, we do this, but who knows what the hell is the real performance 9, 10, 15, 20 years from now? And what are the things that are going to affect that? The natural decay of the systems and elements that you build with. But what else is potentially going to decay energy performance over time? Off-gassing of insulation. This stuff's not prone to that, but blown foams are. What are some of the other things that could really mess up energy performance in a house?
Retrofit and renovation.
That's one. We can't control that, but we're going to have a code for existing buildings that's going to hold renovations accountable to the energy performance. So there will be checks and balances that'll help in that a lot. I wanted to leave you with this, partly because our graphics guys are amazing. This is just everything we talked about as it's identified in climate action and in the governance documents we get out of the province. What I want to leave you with is a little bit of thing to think about here. What are the chances you're ever going to see this? a fragrance called basement. You're not. Because what do basements smell like?
Dank.
They smell dank. They smell like basements. Musty. Not ICF basements, mind you, but basements we've traditionally built with concrete studs. Pink stuff and a 6 mil poly bag in there. Maybe moisture protection on the interface of the concrete. They actually don't even make code. And there's nowhere in the code that it describes that particular basement. It's just the way we've always done it. Remember, nationally, there never was an energy provision until 2015. It's the first time we got an energy provision in the national code, or actually 2010. Before that, when you insulated a basement, you were doing it in accordance with what the provincial code was, and the provincial code up until that point was R12 to 2 feet below grade. What bloody good is that doing in Fort St. John or Fort Nelson at 7-foot frost depth? What is insulation to 2 feet down doing for you? So why did the government put such a horrifically useless energy provision on the basements? Because if you build a traditional batten bag basement, it smells like a basement. It's a combination of influences here, but if you look at how water gets into basements, there's a bunch of ways. Little red arrows here are air leakage. And if you follow those air leakage paths that you see there, look at the top arrow in there, it's warm moisture laden air, and as it passes through that cold air leakage point, what's it dropping off inside your basement? Condensation. You get any kind of reverse vapor drive from this little blue arrow up here. This is when a sprinkler or rain hits the top of the exposed foundation wall, the sun comes out and bakes it in. The momentary vapor drive, when that event occurs, it results in reverse vapor drive, a definite and measurable influx of water through the concrete into that batten bag system. The momentary vapor pressures we get there don't even exist on standard psychrometric charts. We have to use the steam tables that they used for steam locomotives to get the same kind of levels of force that are generated at those temperatures 100% saturated. The problem is, when are you ever going to get that combination of temperature and vapor pressure pushing the water back out to concrete? Because unfortunately, concrete's vapor tight at normal residential loads. So you got lots of ways that water can get in. Look at the gold arrows down on the bottom here. You build something out of concrete which is liquid water porous, vapor tight, but liquid water very, very absorbent. And we stick it in wet dirt, so guess what happens? It hydrates. And we know that because when you retrofit old houses and the sill plate's been placed on top of the foundation wall and there's no gasket underneath there, what happens to the sill plate? It just disintegrates. The lignocellulose goes, it's dry rot, takes 20-25 years. It's a cousin of the wood rotting basidiomycete from leaky condo, but it is nonetheless eating the lignocellulose, the strength fibers in the wood. And it feels like and looks like balsa wood when you pull it out. It's so rotten in there. So we know it hydrates, which means the inside of the concrete wall is always wet. And you got a plastic bag on the inside, and you got concrete which doesn't breathe on the outside, and you got liquid water on the surface of the concrete. If you got liquid water in a glass and you put it on a table, it just evaporates. So it evaporates off the basement wall. So what happens to the relative humidity in that stud cavity? It just goes up and up and up. And it reaches about 80-90%, which is enough to actually take the wood to fiber saturation. And you've ever taken a basement apart where the studs weren't touching the foundation wall, and there was even poly against the foundation wall, and yet the studs are still all messed up? That's because of hydric wetting. It's high humidity loads that transfer into liquid water in the lignocellulose, the open cells of the strength fiber in the wood. And there's no way for it to get out. So they rot and they stink. It's guaranteed. Code says you can't do it. You can't have air and vapor tight material to the exterior of principally insulated walls unless you install them exterior to a drain and vented capillary broken cavity. How do you drain and vent and capillary break the foundation? It's backfilled with dirt. No way to put a rain screen foundation in. At the end of the day, you can't build them. New code doesn't relax on that. So if you're doing this, your results are guaranteed. You're going to have that. So what can we do? Well, there's a bunch of things we can do, but because we want to get going and I want to make sure that I give my time over to drive it here for sure, I want to just finish off with a simple reminder in cross-section of what we're dealing with these walls. Yes, the water comes up. Yes, it evaporates in between the EPS foam and the concrete and the mass wall. That very, very thin air film, because you're casting the concrete up against it, it is the form, by the way. That's why being massive and being intimate, whether through ICF or rigid directly adhered or 2-pound foam sprayed right on interiorly or exteriorly, these all work, and they work incredibly well. And we've got decades of experience with all of those solutions, including ICF, and it's just shown again and again and again that our WUFI hydrothermal modeling, our anecdotal and laboratory, and our build-up and our monitoring projects are all consistent with any kind of review work we do on the whole for basement systems out there. Same hydrothermal performance above grade. So yeah, do we believe in it? Absolutely believe in it. I want to leave you with one other thought on the energy thing. If you build a base house right now, that curve represents the Energuide rating that you would get on the bottom using the old scale versus how airtight you got the house. So here's that average BC, here's the goal we're going to. So if you build a house to the base of the building code with average air tightness, you can have an Energuide rating of about 69. If you build it in the lower mainland with great air tightness, you're going to get 71 on the same thing. 2 Energuide points just by getting it more airtight. Now look at the impact of building a base house and just adding argon to the windows. Almost an Energuide point. Add an air source heat pump to that regular house. And look at where you are. The green is energy efficient. And if you get it airtight, you're achieving the goals that we have for 2020, step 2. That's just putting an air source heat pump into an old pre-2012 house. But the one that I really wanted to point out to you is there's the effect of condensing hot water on a base house. There's the effect of putting R12 under the slab. Almost nothing. Almost a complete waste of time insulating under your slabs. But this is the one that gets me here. Not that one. That's argon condensing and combined. This black line. You build a house today to the rafters in ICF, so basement and walls above grade, and do nothing else different, and your curve shifts from here at the same air tightness, we go from 71 to 76. $2,000 an Energuide point, that's a $10,000 construction advantage right out of the chute. $10,000 extra dollars just on the energy equation alone. And remember, we're building over here actually more at 69, and with ICF you're easily going to get into the sub 1, the sub 2 category for air tightness. So the advantage could be $12,000, $14,000 just on energy. Take out simplicity in construction and everything else. All important observations. Thank you so much, everybody.